Oh yeah, you don't start.
Now, what we're doing at this time is preparation of exodie, and the stage of the work now is to destroy the excess nitrous acid that is present in the diazonium salt that is produced from the diazonium process. Immediately after this, we will go into the coupling reaction where the diazonium salt will be coupled with the appropriate coupling agent. In this case, we are using help me. What are we using? Help me.
We are using 4-aminophenol.
Using 4-aminophenol in this coupling reaction.
Yes.
And you can see we are trying to carefully create streams of the
Protector.
urea, the protector to destroy the excess nitrous acid, so as to avoid vigorous reaction in course of neutralizing the excess nitrous acid. Immediately after now, we'll be coupling, and you can see the dye bath is such that is the ice, the crushed ice is mixed with table salt in order to get a very low temperature. Looking at the thermometer here, you see we're having about -2 degrees centigrade, which is actually very proper for this process. The reason for this is to prevent the loss of nitrogen that is supposed to be used for the coupling. If the nitrogen leaves, eventually it will end up producing a phenol instead of a diazonium salt. And you see, that means your reaction failed. Your reaction failed. If that happens, your reaction fails. So we're trying to avoid the failure of the reaction. You can see I'm almost done with this, and immediately after careful stirring for about 5 to 10 minutes, then I go into the next step of the reaction, which is coupling with 4-aminophenol. This is the next stage of the reaction process. In this stage of the reaction, I'm actually coupling with 3-aminophenol. 4-aminophenol, and you can see as the reaction is going on, the temperature must be kept very, very low, and you ensure that you do not just empty the 4-aminophenol directly into the diazonium salt that is prepared already. You see the temperature is kept very, very low. This is held for this kind of reaction. And looking at the body of the dye bath we're using here, you see it is showing that the temperature is far below 0 degrees centigrade, and that means we are actually getting it right in this reaction process. You see, we are trying to make sure you stir completely for the reaction to go down to completion, because you see diazonium reactions, especially with 4-aminophenol and this kind of starting material, it takes a very long process for the reaction to complete. So we'll keep stirring for a long time for the reaction to go to completion. That's how exactly coupling reaction is done with in preparation of exodie. You can see it's coming out very well. You can see the there. You can see the last stage of the reaction is actually the coupling reaction. That coupling, you can see the dye getting this is a very interesting dye. You can see the shade you can get from this now, although it is not as bright as it should be. The illumination here is not high, but I know you can still see exactly the color of the dye, you see. And we have to maintain the stirring for a very long time because like we said earlier, coupling reactions are actually very slow, and to bring out the color after this, we need to, especially when it has to do with phenols, the phenolic dyes, we try to actually bring out the color using acetic acid at the end of this coupling reaction. That actually bring out the shade of the dye, making the hue of the dye very very deep. You see, this should continue, the stirring should continue for some time, because if the coupling reaction is not actually complete, there is easy disintegration when the dyed fabric is subjected to light. The light fastness of the dye will be low, so this stirring will continue for some time, say about 15 to 20 minutes. Thereafter, you allow for proper dyeing, and it consequently will stir intermittently for about 1 to 2 hours for completion. Fine, really interesting, very fine. See, very interesting. You can see, yeah, I try not to take it out of the water, because taking it out of the ice bath will not be very healthy for the reaction, since we require a very low temperature for this work.